everyone, welcome back to Dragonfly Engineering. This will be the second show in the new molding machine series. And this is in this episode we're actually going to make a simple and quick mold so I can demonstrate the operation of the new molding machine that we showed in the last episode. So, I'd also like to introduce the shop dog, Sierra. You want to say hi, Sierra? She's going to be assisting me in machining as we go. Thanks for making your appearance. In this episode I'm going to show you the process of the basics of an injection mold. And it's going to be a very simple mold, mostly just for demonstration purposes of the molding machine, which will be the next episode in this series. So first episode was receiving and installing the molding machine. This episode is going to be building the mold for the molding machine. And then the subsequent third part of this series is going to be the operation of the new molding machine with this mold that we're going to make today. So some of the parts in this mold are recycled from old molds. I do a lot of quick prototyping of injection molded things. So I have a lot of old molds that I basically just machine off the cavity and add a new cavity to it. So, without further ado, let's get into the process of making a quick mold to demo the molding machine. Oh, and I'm going to try a new feature of the videos this week. I'm going to show some added footage of just some adventures that I do around Northern California and around the world, actually. So this week I'm going to show some footage of sea kayaking off of Santa Cruz Island in Southern California. You can check out some of the local wildlife and some of the sea caves that we kayaked through, and it was pretty fun. Okay, in order to make a basic injection mold, there's a few primary components involved. Here you can see this block of aluminum, which is recycled, is going to wind up being the B side. You can see that there's threaded holes already. And then this block will mount onto the riser blocks and the base piece. And a lot of molds are assembled this way. Actually, my brother John made these for me. He just got a manual mill, and this is one of his first projects. So he made the base and then these riser blocks, which basically has a access for a clamp to clamp the mold down to the molding machine, and some through holes for a bolt to bolt the bottom of the mold together. So these blocks assemble like this, and then the B side of the mold, which is where ejector pins go, bolts onto the riser blocks. And in this cavity here is where a pin array and a plate called an ejector plate will actually push parts off of the cavity that will be machined into this surface here. Then this block is going to be the A side, which will have an alignment ring and a hole through it to inject plastic into the cavity, which will be machined into this side of this recycled block. So this block is aligned to the A side of the block, is aligned to the B side of the block, and the alignment is done with pins. So we're going to machine and press some alignment pins into the A side of the block. And these pins will align with bearing blocks on the B side. So I can draw that out. So I also want to make sure there's no high spots on the corners here to get a better seat of your beginning stock in your mill. So I'm just going around the edges. You only really have to worry about the edges because that's where the parallel is going to interface. So that looks pretty good. Start the block at the end of the parallels, and I basically use the block itself to push any micro chips or particles or dust out of the way. So we got a good seat. Now usually these angle lock vices, I think this is Tico, but Kurt is the same way. A lot of times you'll lift up your stock on this end by about 1/1000th of an inch, just as a function of how the vise locks your stock into place. Another thing that's important, let me make sure you can see, actually I'll adjust here, a practice that I follow when I'm tightening down stock is I don't stick the handle in like this and start hitting the handle this way, because you run the risk of rocking your vise out of square in your mill. So I always like to have the handle where I'm pushing down on the table instead of over. So let me get that pushed down a little bit. And then with a rubber mallet, not a steel mallet, and I don't even like to use a brass mallet because you may damage your ways, but we're going to tap the mold into place. What I'm going to do now is test the parallels to make sure they're not moving. If they're snug in there, that means that both sides of the block are pushing down on the parallels, which are, again, referencing the reference surface of your vise, which is this surface here. All right, so now we're going to load the shell mill, and we will face off the top of this mold. Okay, so this shell mill is what we're going to use, and it uses these round carbide inserts. You can get square or hexagonal inserts as well. But I like these round ones because it makes, in my opinion, the best surface finish, because the full round reduces the scallop height between cuts. So you get more of a mirror finish because there's less of a tooling step between cuts that you do. But yeah, there's 5 of these and it just spins around in here. So let's load this guy. Oh, and then for this Herco mill, there's you need to be careful of which slot goes where. So this slightly deeper slot needs to line up with a longer tang in the spindle here. Like so. I also like to bounce the tool holder a little bit to help push any air or particles or anything out of the spindle that holds the tool. Just provides a better precision on tool repeatability when you clamp the tool into the spindle. And this is going to give us our first reference surface. So just gradually coming down and starting to hit. And then we'll move off a little bit. I like to go down another 10 microns or so, maybe 20. And then we can essentially just manually jog. I'm just going to hold down the jog button, and we'll face off this mill, or this mold. Then you can kind of see the finish that we get there. It's a pretty good finish. The finish isn't too critical here because we're just working on the parting line, but that's a typical shell mill finish with a round tool. These inserts are, I think, 1/2 inch carbide.
Okay, now we're going to flip this mold block around and get ready to machine the rest. And basically the same process. I wiped out any particles on the parallels. And with a rubber mallet, I'm going to seat the block. I usually tap the handle in the mold a few times, and I test to make sure that the parallels do not slide underneath the block.
So we should be nice and square onto the vise. And then we do the same thing, and we cut the top to be square. Lightly deburr the sides. The main purpose of this step is because we're going to edge find this, or find the corners of this mold next with a edge finding tool, which basically just wobbles on the side. And we don't want to find the edge of a burr, we want to find the actual edge of the block. All right, so this is the Toolpath program that I use. It's called Visual Mill 5, and it's a very old program, but it works pretty good for me. This is a toolpath that we're going to cut. So the light blue lines are linear machine cuts. The dark blue lines are round G-code cuts. And then we've got the tool spiraling in, which is all of these kind of pinkish purple cuts. So what we're going to do is using the 1/2 inch end mill, we're going to cut out basically this pocket shape, leaving a round disc in the middle, and then machining out a pocket in the middle. Yeah, so let's do it. All right, so let's start her up, and with both fingers, one finger on the start button, one finger on the hold button, we will let her rip here. And RPM looks good. I usually like to stop it right before it's going to hit the top of the stock anyway, and just double check that my numbers are looking good, and they are. So we'll go ahead and let it cut. And now I'm going to increase the feed up. And then the end mill is a center cutting, but usually the CNC program will figure out a way to spiral the tool in so that you don't bog down the center of the cutter. So there it did a ramp down, and now it's starting to do the actual cut. I think I probably will do a little coolant. Let's see if it sprays all over. I can reduce the coolant amount. That way we don't flood the camera or the shop. And that's it. So I think this operation is about maybe about 3/4 of an hour or so. And we'll just let it go, and I can start on the other side of the mold on the other milling machine. Okay, so the mill's in tool position 4. So we load our drill chuck and then hit the button there. And then since we're already here, I'll go ahead and set the tool height of this mill, or this drill. And the drill's not too critical, so I'm just gonna eyeball it. You only really need to be precise. Okay, so I found a tool holder with the ER16 collet. So I'm gonna pull out this 3/8 end mill. And then replace it with a 3/8 16 gun tap, I believe that's what it is. Yeah, and then the shank is the same size as the 3/8 end mill. So we can use the 3/8 ER16 collet and stick that in there and then tighten it down. So this milling machine does rigid tapping. So it synchronizes the spindle with the Z-axis travel to match the helical travel of the teeth on the tap. So it's basically 1/16 of an inch in Z-axis travel per revolution of the tap, very precisely, so that it doesn't wind up breaking the tap off. And then we pull this guy out, and that's our setup that we're going to stick into tool position 5 of the mill. Hi folks. All right, so I'm on the GoPro for a little bit while the other battery and the other camera charges. But I wanted to show you what our part is going to be, our injection molded part. So this is basically a tab or a coupon that we're going to make to test the shrinkage of the plastic, like I mentioned earlier. There's going to be two squares, 1-inch squares that are nested together. One of the first square, which is shown by this Toolpath, is going to be 2 millimeters thick, and then the second square is going to be this guy, which is going to be 1 millimeter thick. You can see the origin of our part, which is going to be the ejector pin sprue location, which is here. And what we're going to do is drill 2 ejector pin holes in the part. These are going to be 5/16 in diameter, and so this is the drill path for that. And then this is the ream, which is overlapping the drill. Okay, we're on the second mill, and this is with the B-side mold block, and this is the one I recycled. You can see we've got some bearing holes already pressed, and I basically just machined off the top of those bearings. And since this is going to be a mold that isn't used very much, it's okay to have these rough edges on the lining for these plain bearings. I can show you more about them. Up here is just some remnant features from the last mold cavity, so we're going to machine our cavity on this side. But what I need to do is find the center of this sprue location, and then that will set our program location to run the program that I just showed you. So let me switch to tool number 20. And this is called a center finder. So there's a cone here which can wobble back and forth, and when you use the center finder to find the center of a hole, you don't turn the spindle on, but what you do is you bring the tool down, and you basically stick that cone right into the hole that you're trying to find the center of. So let's do that. I'm holding the GoPro by hand, as you can tell. So we'll bring this tool down, and then we gotta wiggle it to see, and it looks like it's already tight, maybe a little too tight. We can come up a little bit. It helps to keep your tool a little loose in the tool holder so that you don't overrun and damage your center finder. So now what I'm going to do is move back and forth, and you essentially want to feel the shaft, and until you can no longer feel that ledge between the two 3/8 cylinders, and you're basically driving the location by the cone being in your hole. So when you can no longer feel any kind of ledge, and I'm moving 1/2 thousandths increments here, that tells you that's your center. Over here we can do part setup, work offset, and then for X we will tell it to store machine position, and Y store machine position. For the CNC folks, I'm working on a G54 coordinate system, and you can see up here it's saying part is 00 when the center finder is on the center part of our mold here, which is how I wrote the program. Alright, so now we're going to lift the center finder out, and I've already set the tool heights, so we can go ahead and run this program. I'm going to reduce the feed rate down to very small and the rapid to very small. We can keep the spindle speed up. And then I'm going to press the start and the feed hold. So start button, feed hold if something doesn't look right. And I'm keeping my thumb on the feed hold button just to make sure everything is good. You know what? I think I need to center drill this first. 1 second. Let's cool it in a reasonable location. And we got our friend Sierra here who's checking in on the operation. That's why I closed this gate, because I need to come up with dog safety glasses. Hello Sierra, how you doing? All right, next page. We'll lower the speed down. Okay, so I flipped the B side of the mold over onto its back, and you can see how there's already some features there. We've already got the threaded holes for the riser block, since this is a recycled mold. These are the broken through ejector pin holes there and there. But now what I need to do is machine the bearings to support the ejector plate, which is going to be a plate of metal that spans across the back of the mold between the riser blocks. And to do that, we need a couple of bearings, linear plane bearings for 3/8 inch rods, which will be the guide rails for the ejector plate. So I've got the tool set, and I went ahead and set the center drill this time. So let's go ahead and start machining a couple of bearing holes and some drilled and reamed 3/8 holes for the ejector, or for the guide rails for the ejector plate. The reamer is actually 376 thousandths to give a little extra room for movement. So here we go. Okay, I updated the program for the proper diameter for the 3/8 bushing. This diameter is for a 1/2 inch bushing, so I was a little off. I'm so used to using 1/2 inch bushings. Anyway, so let's go ahead and start this thing. We should get the right cut this time. I also had to cut the whole pocket in one shot. I think we're still going to break out, but that's okay if the bushing is poking out the side. Sometimes it makes it easier to remove the bushing after if you need to replace it. You got a ledge to knock on. This is the 376 thousandths reamer. Basically adds additional bearing for the injector plate rods, which are 3/8 of an inch for 375. All right. So the final step is to measure the 4 corners and make sure they're all the same height. Hi everyone. Well, it looks like this video is going a little longer than I anticipated. I think we're at like 35 minutes so far. And we still have ejector pins to cut and grind, an ejector plate to make, guide pins to press into the mold, and then the final assembly of the mold. So it looks like we're going to split this video into 2 segments. So I think this will be a wrap for the first half of mold making, but I will keep my promise and show you some of the footage of sea kayaking around Santa Cruz Island in Southern California. So I hope you enjoy, and I'll see you next week. All right, I'll sign off. Thanks a lot. Hey, buddy.